Good morning, dear students. Welcome back to physics class. Today, I would like to present a new topic which is analytical method of vector addition. At first, let me try to do a simple attempt to recollect you the previous learned parts. What are the two graphical methods of vector addition? Can you say about them? They are, first one is triangle rule or method and second one is parallelogram rule or method. Do you know what is one important drawback of this graphical method of vector addition? It is sometimes tedious and has limited accuracy, even though this method of vector addition helps us in visualizing the vectors and the resultant vector of this vector addition. So it is much easier to add vectors by combining the respective components. Then we can say that this method of vector addition is called analytical method of vector addition. Consider two vectors, vector A and vector B, in xy plane with the components Ax and Ay for vector A and Bx and By for vector B. Then we have the vector A is equal to Ax I cap plus Ay j cap, where Ax and Ay be the x and y components of vector A, and vector B is equal to Bx I cap plus By j cap, where Bx and By be the x component and y component of the vector B. Let R be the resultant vector of their addition. So the resultant vector R is written as vector R is equal to vector A plus vector B. So the resultant vector R is equal to Ax I cap plus Ay j cap plus Bx I cap plus By j cap, which is the expression 1. As vector addition obeys associative law as well as commutative law, so the expression 1 can be arranged and regrouped as vector R is equal to Ax plus Bx I cap plus Ay plus By j cap. Since vector R is equal to Rx I cap plus Ry j cap. Here, Rx is the sum of x components of vector A and vector B, and Ry is the sum of y components of vector A and vector B. Then Rx is equal to Ax plus Bx and Ry is equal to Ay plus By. It is understandable that each component of the resultant vector R is the sum of the corresponding components of the vector A and the vector B. In 3 dimensions, how many components should be there for each vector? There should be 3 components, x, y and z components. Then in 3 dimensions, we can write the vector A as vector A is equal to Ax I cap plus Ay j cap plus Az k cap, and vector B can be written as vector B is equal to Bx I cap plus By j cap plus Bz k cap. Then the resultant vector R is equal to vector A plus vector B, which is equal to Ax I cap plus Ay j cap plus Az k cap plus Bx I cap plus By j cap plus Bz k cap. Then by rearranging and regrouping this expression, we get the resultant vector r is equal to ax plus bx I cap plus ay plus by j cap plus az plus bz k cap. So, this expression can be written as vector r is equal to rx I cap plus ry j cap plus rz k cap, which is the expression 2, where rx is equal to ax plus bx, ry is equal to ay plus by, and rz is equal to az plus bz. One advantage of analytical method of vector addition is that it is useful to add and subtract of any number of vectors. That is, this method can be extended to addition and subtraction of any number of vectors. Suppose we have three vectors, vector A, vector B, and vector C. In three dimensions, these vectors can be analytically written as vector A is equal to ax I cap plus ay j cap plus az k cap, vector B is equal to bx I cap plus by j cap plus bz k cap, and vector C is equal to cx I cap plus cy j cap plus cz k cap. Let us take the resultant vector T as vector A plus vector B minus vector C, which has components as Tx is equal to Ax plus Bx minus Cx, Ty is equal to Ay plus By minus Cy, and Tz is equal to Az plus Bz minus Cz, which is the expression 3. How can you do that? At first, the resultant vector T should be written as vector A plus vector B minus vector C. Then, this expression should be rearranged and regrouped as vector T is equal to Ax plus Bx plus Cx I cap plus Ay plus By plus Cy j cap minus of Az plus Bz plus Cz k cap. Then it will be in the form of the resultant vector T is equal to Tx I cap plus Ty j cap plus Tz k cap, where Tx is equal to Ax plus Bx minus Cx, Ty is equal to Ay plus By minus Cy, and Tz is equal to Az plus Bz minus Cz. Analytical method of vector addition in 2 dimension and in 3 dimension is given in this slide. Please, you have to review it once again. Let us solve the given problem. Question is, find the magnitude and direction of the resultant of two vectors, vector A and vector B, in terms of their magnitudes and angle theta between them. When this problem is solved, there are two laws formed, which are first one law of cosine, second one is law of sine, which you can study by solving this. As shown in given figure, OP and OQ represent the two vectors, vector A and vector B, making an angle theta. By using the parallelogram method of vector addition, OS represents the resultant vector R. Then the resultant vector R is equal to vector A plus vector B. Please you see the figure again. Here Sn is drawn perpendicular to OP and PM is drawn perpendicular to OS. Let us consider the right triangle ONS. By applying the Pythagoras theorem, hypotenuse square is equal to base square plus altitude square, which is equal to ON square plus SN square, which is the expression 1a. But we have ON is equal to OP plus PN. Here OP as the magnitude of the vector A, which is A, and Pn as B cos theta. How should be Pn equal to B cos theta? Here we have considered the right triangle PNS. From this right triangle PNS, cos theta is equal to adjacent side divided by hypotenuse. Here adjacent side is Pn. So Pn is equal to cos theta into hypotenuse. Hypotenuse as the value of magnitude of the vector B, which is B. So Pn is equal to B cos theta. Then On is equal to A plus B cos theta. Consider the right triangle PNS again. Then what should be the sin theta? Sin theta is equal to opposite side divided by hypotenuse. So sin theta is equal to Sn divided by B. Then Sn is equal to B sin theta. Then you have to substitute the values of Sn and On in the expression 1a, where OS as the magnitude of the resultant vector R. Then the expression 1a becomes as R square is equal to A plus B cos theta all square plus B sin theta all square. So R square is equal to A square plus B square plus 2AB cos theta. By taking the square root, the magnitude of the resultant vector R is equal to square root of A square plus B square plus 2AB cos theta, which is the expression 1. The expression 1 is called law of cosine. To get the expression 1, we have used here two mathematical properties, which are, first one is A plus B all square is equal to A square plus B square plus 2AB. Second one is the trigonometrical property, that is sin square theta plus cos square theta is equal to 1. And in the right triangle PSN, sin theta is equal to Sn divided by Ps. So Sn is equal to Ps sin theta, which is equal to B sin theta. These two expressions are represented by 2a. As the LHS of these expressions are equal, then their RHS also should be equal. So it can be written as R sin alpha is equal to B sin theta, then R by sin theta is equal to B divided by sin alpha, which is the expression 2. Similarly, we have considered two right triangles PMO and PMS. From the right triangle PMO, sin alpha is equal to PM divided by A, then PM is equal to A sin alpha, and from the right triangle PMS, sin beta is equal to PM divided by B, then PM is equal to B sin beta. From this expression, it can be written as A divided by sin beta is equal to B divided by sin alpha, which is the expression 3. By combining the expressions 2 and 3, we get r by sin theta is equal to a by sin beta, which is equal to b by sin alpha, which is the expression for. This expression is called law of sine. From the expression for, we have sin alpha is equal to b by r sin theta, which is the expression 5. From the right triangle ONS, tan alpha is equal to opposite side divided by adjacent side, which is equal to Sn divided by On is equal to Sn by OP plus Pn, which is equal to b sin theta divided by a plus b cos theta, which is the expression 6. Then the expression 1 gives the magnitude of the resultant vector r, and the expressions 5 and 6 give its direction. This slide shows the mathematical expressions of the two laws, which are law of cosines and law of sines. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.